Hi girls, this is Miss I. We are going to work through a couple problems where you are going to be trying to solve. We're going to solve together the sides of triangles, right triangles, using trig functions, all right? And there are two different kinds of problems you're going to find this way where the placement of the variable and what you're solving for is different, and I want to show you both different types so you can handle either of them. Let's start with this triangle here, all right? And the first thing you always want to do is make sure it is a right triangle, because you cannot use a trig function if it's not a right triangle, and we have that confirmed here. Next thing I want to identify is what information do I have, and that's a 65-degree angle there, and I have one side of 15 centimeters, and I'm trying to solve another side of x centimeters. So that's helpful, because I know that I've got a side at an angle, and I'm trying to solve for a side. Now, what I want to do probably first is label my sides and find my hypotenuse, find the side that's adjacent to the angle, and the side that's opposite to the angle, so I'm really clear about my sides. And then I want to take those and figure out, well, what am I working with? In this case, I'm working with, and this is about sides, right? I'm working with a hypotenuse, and I'm trying to solve for an opposite. So what I want to do is look at my trig functions. See, I've got them down here, and identify which one of them uses the relationship between opposite side and a hypotenuse. And that's my sine function, right? Right here. Oopsie, right there. So I'm going to set up my problem using sine of 65 equals the opposite, which in this case is a value of x centimeters, over the hypotenuse, which in this case is 15 centimeters. And this is the problem I'm going to solve. Now your calculator is going to give you, if you type in sine, it's going to give you automatically the open parenthesis, and then you're going to need to type in the 65 and the close parenthesis, all right? Because what we're doing here to solve, right, is we're going to take this 15 that's in the denominator and multiply it against both sides. That way it cancels here. So what I'm really solving here with my calculator is taking sine of 65 and then multiplying it, and you can do your little star sign on your calculator or use another parenthesis, 15. My answer on my calculator is 12.4024319, and that means we're going to say that x is equal to approximately, not exactly because we are going to round to three significant figures, to 12.4. And make sure we bring in our units, right? Because this is a problem where we have units. And I want to always ask myself, before I move on, does this answer make sense? Does it make sense that a triangle with a hypotenuse of 15 centimeters, the longest side, would have one of its shorter sides, right? The other two sides be about 12.4 centimeters. And in fact, that does make sense. So I can move on to my next problem. But before I do, let me just go back and point one thing out. Our variable was here in the numerator, right? So all we had to do was multiply 15 times sine 65 to solve for x. Notice where the variable ends up in the next problem. So here's my next problem. Again, I check, is this a right triangle? Yes, it is. And I have enough information. I have 2 bits of information, and I'm solving for a third, so I can use a trig function. Probably. We're going to check this out. First thing I want to do is label my sides. So I'm identifying the hypotenuse, the adjacent side, the opposite side, and I'm noticing, well, what am I solving for here? I'm solving for the side here, of the adjacent side, and I'm given the opposite side. So the trig function that uses opposite and adjacent, well, in this case, that would be tangent, right? Opposite and adjacent, see that? So that's what I'm going to do to set up my problem. So I'm going to take my tangent of 42 degrees and put it equal to, and you always put the degree with the trig function in a parenthesis like this, all right? And on the other side of my equal sign is my fraction, which is the relationship between the two sides. So in this case, it means I'm writing in 6, the opposite value, over x, the adjacent value, right? Because that's my tangent ratio. Notice the location of my variable. The x is in the denominator. On the last problem, the x was the numerator. I could just cross multiply, be done. But now I need to figure this out. I have to solve for x, and x has to be in the numerator for me to solve for it. So what I'm going to do is I'm going to multiply both sides by x. That way x's cancel over here to 1. And now I have tangent of 42 times x equals 6. Make sure that makes sense to you before you move on. If I were solving for x here, and let's just say it had been, let's say it had been 3x equals 6, what would I do? I would divide both sides by 3, right? Same thing. You're going to divide both sides here by tangent of 42. It's the same mathematical process. We are not changing the value of the overall equation. We are dividing by tangent of 42. And I'm just, this is all simply doing the algebra, the math of it. We haven't touched my calculator yet. So I'm going to rewrite that. And what I'm going to put into my calculator is this, 6 divided by the tangent of 42. And I get 6.66375 or something like that. So x is equal to, do my little approximately, 3 significant figures, 6.66 meters. And what I want to do again is go back to that problem and say, does it make sense that x equals 6.66 or almost 6.7 centimeters? If x equals 6.66 meters, does that make sense? This side, this angle would be approximately, we know this just doing quick math, right? We know this is going to be 48 degrees. So the side opposite the 48-degree angle is going to be longer than a side that is opposite the 42-degree side. So it makes sense that this side should be a little longer, even though it's not drawn that way. We're not drawn to scale. This is a little longer than the 6 meters. And that makes sense numerically. So yes, I'm good, I'm done. And now you see those two different ways that you can check it, right? Variable in denominator and variable in the numerator. That's it. Go try some problems, all right? See me if you need help.